We're taking what we did yesterday, building on a little bit. The sheet that you took notes on will be on the back side of that sheet. Today we're going to do cube roots. Similar to square roots, obviously not the same though. So to start with, when we are cubing a number, anybody remember what power we're raising it to? What's the exponent for a cube? 2 a square. 3. Think of it this way. When you have a square is a 2D shape, right? When you have a cube, and not a great drawing, but you know, a cube is a 3D shape. That D is for the dimensions, length and width for a 2D shape, length, width, height for the 3D shapes. That's where those exponents are coming from, okay? So when we cube something, we're raising it to the power of 3. So you can see over here on the right, the cube root symbol has a little 3 on it. And a cube root, just like a square root, is the inverse operation for that. What's inverse mean? Reverse, opposite, backwards, right? So it's the inverse operation for cubing. What you're doing then is you're looking at what number times itself 3 times equals that number in there, okay? So square root was just 2 times. Cube root, we got to figure out how many or what number goes in there 3 times. A little bit tougher, and it gets a little bit bigger numbers when we do it this way, okay? Oh, I forgot to change that to a cube root. My fault. That should have a little 3 there. So if I got the cube root of 27, what we're looking for is what number times itself 3 times equals 27. Keller? 9. 9 times 9 is 81. 81 times 9 is 729. So it's not 9. Corey? 3. 3 times 3 is 9. 9 times 3 is 27. So the cube root of 27 is 3. Okay? You see what I'm saying on how this one's a little bit trickier, right? Everybody follow with how we got that though? Or how this is supposed to work at least? So it does get a little bit trickier that way. One of the ways we're going to help you out for today though, you see that little chart on there? We need to fill those in, okay? So 1 to the 3rd power. 1 times 1 times 1. What's 1 times 1 times 1? 1. All right, y'all fill in the rest of those. Eventually, if we work with these long enough, you'll get kind of some of these memorized a little bit or get a little quicker with them. For today, I would definitely keep this sheet of notes with you. It will make things go much smoother. Just because I'm seeing some mistakes. What's 2 to the 3rd power? Who can raise their hand and tell me? Hunter? No? Keller? 8. 2 times 2. 2 times 2 is 4. Times 2 is 8. So 2 to the 3rd power is 8. Everybody see what I'm saying? I saw a few of y'all had 6. We're multiplying, not adding. Who can give me third power? Corey? Yeah, 27. That's the one we just talked about. All right, 3 times 3 is 9, times 3 makes 27. How about 4 to the third power? Adam? 64. This one gets used a lot in 8th grade math. All right? When we did square roots yesterday, what was the square root of 64? Square root of 64 is 8. Cube root of 64 is 4. So that's why it gets used a lot. That's one of the few numbers that has a square root and a cube root. So they sometimes use that one, kind of try to trick you a little bit. All right, who can give me 5 to the third power? Connor? Nope. Keller? 125. 5 times 5 is 25. 25 times 5 is 125. Like if you had 5 quarters, that'd be $1.25. These get a little trickier, especially some of y'all maybe have a hard time with your multiplication. That's why having this list is going to be a little helpful for you. 6 to the third power. Adam? 216 is correct. 6 times 6 is 36. 36 times 6 gives you 216. 7 to the third power. Corey? Yeah, 343. 343 is correct. 7 times 7 is 49. 49 times 7 is 343. And we got 8 to the third power, not yet. Not yet. Corey, what you got? 512. 8 times 8 is 64. 64 times 8 gives you 512. Nine to the third power. 729 is correct. Nine times 9 is 81. 81 times 9 gives you 729. All right, 10 to the third power. Keller? 1,000 is correct. Ten to the third power is a 1 followed by 3 zeros. For stuff that we'll get to later this year, we'll work with 10 with different exponents more. And whatever 10 is, whatever the exponent is, just tells you how many zeros you put on it. So like 10 to the 8th power would be a 1 and 8 zeros. So 10s are usually pretty easy to work with. Any questions on any of those? Everybody got that list copied down on your paper? Like I said, this list is going to make things a lot easier for you for the other stuff we're doing with this, okay? Eventually, as you work with it, you'll start to memorize some of them. All right, so Y'all go ahead and try 6, 7, and 8. Don't do number 9 for right now. Number 6, Jaden. I'm going to give it to you. It's just positive. Cube root of 512 is positive 8. All right, yesterday with the square root, it could be positive or negative, okay? I'm going to show why. I'm going to use ones to show you why, okay? So for the square root of 1, if I had 1 times 1, that's positive 1. If I had negative 1 times negative 1, negative times negative makes it a positive, right? That's why both of them could be the square root of 1. If it's the cube root, if I do 1 times 1 times 1, that's still 1, right? But if I did negative 1 times negative 1, negative times negative makes it a positive, right? And then a positive times a negative makes it negative, okay? So that's why the answer is only going to be positive. For the answer to be negative 8, we'd have to have the cube root of negative 512. Y'all follow on what I'm saying there? All right, number 7, Jacob. Negative 125 is correct. So similar to what I was just saying with the squares from yesterday, when it was in the parentheses yesterday, that made it a positive, didn't it? But because it's a negative times a negative times a negative, that keeps it as a negative, okay? Cube root of 216. Corey? 6 is correct. All 3 of those, that chart was pretty helpful, right? Right? How we got what? You're looking for what number times itself 3 times equals that number. So 6 times 6 is 36. 36 times 6 is 216. That's where those numbers come from. When you're looking for the cube root, you're looking for what number times itself 3 times equals that number. All right, so I didn't have you do number 9 because we hadn't done a fraction yet. There's 2 ways you could do the fractions, okay? If it's 1/4 to the 3rd power, we could do 1/4 times 1/4 times 1/4, right? So if I did, like I just said, 1/4 times 1/4 times 1/4, 1 times 1 times 1 is 1. 4 times 4 is 16, times 4 is 64. Okay? Everybody good with that? That part makes sense? So that's one way you can do it with a fraction. The other way you can do it with a fraction is instead of multiplying the whole fraction, I can take that exponent and put it with the numerator and put it with the denominator. So I could have 1 to the 3rd power over 4 to the 3rd power. Y'all see that right there? So 1 to the third power is 1. 4 to the third power is 64. You still end up with the same thing. You still end up doing basically the same math. You got to do 1 times 1 times 1. 4 times 4 times 4, right? So either way works. Sometimes doing it this way here on the bottom is going to be a little bit easier when we get to more complicated things, though, okay? Any questions on that? Fractions ain't too much different with this. It's just do the exponent for the numerator and do it for the denominator. All right, so I'll do A. What do we do to solve this? If I've got p to the third power equals 64, Taquan? No. Jaden? Yes, but what we're doing is we're going to take the cube root, okay? That's what we're doing. If we have p to the third power or whatever variable to the third power, we solve by doing the opposite, by doing the inverse operation, right? Y'all remember with the exponents of 2 yesterday, we took the square root, right? So if we got an exponent of 3, we're taking a cube root. If we take the cube root on one side, we got to take it on the other. Cube root of something to the third power is just going to give you whatever that something was. Then, when we're taking the cube root of 64, we're looking for what number times itself 3 times equals 64. Jaden already told us that'd be 4. 4 times 4 is 16, times 4 makes 64. Everybody good on that? All right, y'all do. Little table there should be making this hopefully pretty easy. It's kind of almost just matching at this point. Who's got me? Carlea? 10's correct. 10 times 10 times 10 gives us 1,000. So when we're solving that, we're taking the cube root of each side. Cube root of 1,000 is 10. All right, C. Nick? 5 is correct. Same idea. Cube root of each side. Cube root of 125 is 5. 5 times 5 is 25. 25 times 5 gives you 125. Okay? This is definitely tougher than square root, right? These aren't ones that you just will automatically recognize always. Using that chart, at least to start with, is going to help a lot with this.